All right, I just wanted to go over one more example with you guys before you started your problem set today. What we're getting introduced to is this new equation of VF squared equals V naught squared plus 2A delta X. So that's that our final velocity squared is equal to our initial velocity squared plus 2 times our acceleration times our displacement. What our problem is that we have a park ranger and he is driving on some backcountry roads at night, and he comes across something that I'm sure we've all seen before, which is a deer. So he sees 20 meters away from him a deer just stuck standing still in his headlights, not even knowing to move, okay? It's like freaked out. And he is driving, when he sees this, at a speed of 11.4 meters per second. And hopefully you are like the park ranger, and the first thing you do when you see a deer in the road is you slam on your brakes to try and stop, okay? When he slams on his brakes, his acceleration is now going to be against him. So it's going to be negative 3.8 meters per second squared, all right? If he's stopping, if he's coming to a brake, what should his final velocity be? What's your final velocity when you slam on your brakes? Hopefully, your car stops and you get a final velocity of 0 meters per second, okay? VF equals meters per second. What we want to find is how far he goes until he stops. So our hope is it's not this full 20 meters because we don't want to hit the deer. So the question is, does the park ranger hit the deer? Does he not hit the deer? So let's see. If we take this equation right here of this, of this VF squared equals V naught squared plus 2A delta X, and we want to find how far he goes until he stops, it means what we're looking for is this delta X, okay? So we're going to need to rearrange the equation. The first thing we're going to do is we're going to subtract V naught from each side. After that, to get the delta X alone, we're going to divide both sides by 2A. So now we have our final velocity squared minus our initial velocity squared over 2 times our acceleration is equal to delta X, which means we can plug in our values. VF is 0, V naught is 11.4, and our acceleration is negative 3.8 meters per second squared. So that will be 0 squared minus 11.4 meters per second squared divided by 2 times negative 3.8 meters per second squared. Okay, type that into your calculator and see what you get. You should have gotten 17.1 meters. That is how far it takes until the ranger comes to a full and complete stop, which means thankfully he did not hit the deer. Another thing, just really quick, is I'm letting all the classes here know which 3 equations I used to solve the problem set for today, so I'm going to let you know which 3 equations they are, all right? The 3 equations you'll use today solving your problem set are VF squared equals V naught squared plus 2A delta X. That X final is equal to X initial plus V initial times T plus 1/2 A T squared. And then finally, that acceleration is equal to final velocity minus initial velocity over final time minus initial time. Those are the 3 equations I used to solve the problem set. So when you're going through and you're listing your knowns and unknowns, compare and contrast them with these 3 equations to see which one is going to give you the best results. So remember, you want an equation that one has everything that you have and everything that you're looking for. So you want to make sure that you're only missing one thing in your equation, and then that one thing that you don't have a number for is the one thing you're looking for. Lastly, I mentioned when I was grading some of your stuff yesterday you guys didn't know, if you could just show your work, it's gonna help me a lot. Because then when I go through and grade, I can actually give you feedback because I can see what you did wrong to try and maybe help move you in the direction of doing it right next time, okay? I hope you're all doing really well. And remember that you can tune in today between 9:45 and 10:15. 9:45 and 10:15, if you have any questions at all, I'm gonna have our Google Meet link open, okay? I hope to see some of you there. Have a good day.